Let's consider solutions and their concentrations. Most of chemistry occurs in solution. So we have compounds dissolved in water. As humans, our bodies consist mostly of water, so we're a giant beaker that allows chemical reactions to take place. And the easiest way to measure liquids is by volume, and so we define concentration as the amount of something, of a substance, divided by the volume of that solution. One of the most common concentration units is called molarity, and it is given the symbol capital M, and it is defined as being the number of moles of the solute divided by the volume of the solution in liters. So we have liters of solution. Now say if we take sodium chloride and dissolve it in water, then sodium chloride is the solute, water is the solvent, and both together form a solution. Say if we have 10.0 grams of sodium chloride in 250 milliliters of solution. We want to know what the molarity is equal to. Well, we'd have to find the number of moles of sodium chloride. So that's 1 mole per 58.5 grams of sodium chloride. So that's 0.17 moles of sodium chloride. So the molarity would be equal to 0.17 moles of the solute divided by the liters of the solution. And so 250 milliliters equals 0.25 liters. So that would be a 0.68 molar solution. Now when sodium chloride dissolves, it breaks up into sodium plus ions and chlorine minus ions, and we determine the moles of the solute. What if we wanted to know the concentration of sodium plus ions in solution? Well, we look at this balanced equation and we see that there's a 1-to-1 ratio of sodium chloride to sodium plus, and so the molarity would be equal to 0.17 moles of sodium chloride times 1 mole of sodium plus per 1 mole sodium chloride. That's a conversion factor from that balanced equation right there. So that's the moles of sodium plus divided by the liters of solution, 0.25 liters. So that would also equal 0.68 molar. Now what if we had a 0.4 molar solution of magnesium chloride? You'll notice there are 2 chlorines in each molecule of magnesium chloride. And so we want to know what the concentration, the molarity of chlorine minus ions are in solution. So we would have to look at the balanced dissolution equation. So that would form magnesium 2 plus, because it's in group 2A, plus 2 chlorine minus ions. So if we had 0.4 moles of magnesium chloride, we would multiply that by the conversion factor from the balanced equation, 2 moles chlorine minus per 1 mole magnesium chloride, and then divide that by the liters of solution, 1 liter. So that will give me 0.8 molar of Cl minus ions. So we don't always have to go through this calculation, because we can easily see that there is a 2-to-1 ratio, 2 chlorine minus ions for every 1 magnesium 2 plus. So if this is 0.4 molar, then chloride minus ion would have to be double that, or 0.8 molar.